under the properties of alkenes, we have taken already in the last class the electrophilic addition, including the free radical addition reactions and their features. Then second property we have taken oxidation under this reaction with permanganate and ozone and such a reagent. Then the third property let us take today. So, let us take the third property, that is polymerization. As we have seen, alkenes are rich with electrons, they are readily undergoes oxidation, they undergo electrophilic addition. Even this polymerization is also one of the continuation property of that unsaturation and electron rich. They are unsaturated, therefore, they undergo addition, but if nothing is there, they themselves undergo one add on the other one, giving a bigger molecule, and again that add on the other molecule, giving a very big giant molecule formation. So, the process of joining the smaller molecule relatively and giving a large size giant type of the molecule formation is defined as polymerization. Poly stands for the many, mer stands for the molecules. So, many molecules join to give a single large sized molecule is called polymerization. In the polymerization, we can take the smallest example, ethylene, and polymerize it. You will get a n number of ethylenes will join. You will get a big long chain, it is continued by the same unit CH2, CH2, CH2 and so on with n number, let us write. If this is called ethylene, commonly, then the product is called a many molecule joint, therefore, I call it as a polyethylene. Polyethylene may also be called as polythene. Also, they are called as polythene. So, polythene is a large sized long chain molecule created out of the first molecule ethylene. So, this ethylene is called monomer and that is called polymer. So, some number of times questions may be asked, what is the monomer of so and so compound? Means starting material, in fact, the one which undergoes several times the process called polymerization to give this polymer is called polyethylene. And how this reaction takes place means this can be catalyzed. Many times a catalyst will be used under some specific temperature, and the pressure also will be there. Heating and the pressure is two other factors. Now, how exactly the catalyst make a role means, for example, in acidic medium, that is acid catalyzed reactions, ethylene reacts with a proton supplied from the acid. This proton, if I shift this 2 electron this side, this proton will be added on this carbon. After getting the minus charge, the proton is also added on this carbon. So, this CH2 will become into CH3. So, this side you will get a carbocation. After polarizing, you will get a minus, and the minus H plus is added. So, the other side carbon you will get a carbocation. Now, this will be added on the another ethylene molecule. Take second molecule of ethylene, polarize into minus and plus, and the minus, this plus will be added. So, this attacks with this one. So, you will get a 4 carbon chain ending with again with the CH2 plus, and so on. That will attack on the another molecule, and reaction continues to get a large scale. It is evidently that you can observe that the first one starting one is cation, H plus, catalyst is cation, and after attacking the cation on the molecule becomes into intermediate 1. This is cation, this reacts with this one, another intermediate, that is also again cation. So, throughout the reaction you find cation, cation, cation. What happens at the end? At the end there may be 2-3 different types of the reaction. For example, this is the cation we have. One of the most possible situation is drop this hydrogen, the 2 electrons will go here and the double bond is formed, this H will come out. So, therefore, in the polymer, at the end of the polymer you find a double bond with CH2 and CH, and 1 H plus will be given out. That means initially we are using the proton to continue the reaction. At the end the proton is given back. So, this proton goes back to the catalyst. From the catalyst it has come. So, from the catalyst a proton. Catalyst is acid like HCl, sulfuric acid and so on. From the acid it proton. If base is used, a OH minus will come. That minus will attack, you will get anion. So, the method is called anionic polymerization. In the acid you find all cation, therefore, it is called cationic polymerization. Similarly, if free radical is used, all intermediates will be radicals. So, we call radical polymerization. Oftenly we use this acid catalyzed polymerization. At the end again regenerating that catalyst, that is proton, and giving back alkene will be having a double bond at the end, right. So, now this polymerization will become rather somewhat more easy when a molecule contains either a methyl group, say let is chlorine is there. The chlorine will have two effects. It will have the minus I effect, it will induce the double bond polarization, or it can have the a lone pair is there, so it can donate. So, induction of electron through the bond, sigma bond is minus I effect. Over the electrons, resonance showing is plus M effect. Either by effect the chlorine makes the cloud to distort or to mobilize more quickly. So, the polymerization of this vinyl chloride when compared with ethylene will become much more easy. So, therefore, the catalyst consumption, that is heat and pressure, will be less condition. You will get the better polymerization, and the polymer is called now just same polymer except one chlorine will be hanging group will be there, N times will be there. Call this compound as a chloroethene, or we have a common name called vinyl chloride, vinyl chloride. So, the product is called polyvinyl chloride, polyvinyl chloride, shortly known as PVC. It is popularly known as a plastic material. PVC plastic is very much popular, used in the electrical pipes and water pipes and the sheets and lacquers and all that. Several the applications are there, sheets, flooring sheets and water toys and so on. So many PVC plastic the applications are there. Now, that is prepared from the vinyl chloride. So, question may be asked, what is the monomer of PVC? PVC stands for polyvinyl chloride. So, vinyl chloride is the starting material, or the one single molecule that polymerizes to give a polymer is called polyvinyl chloride. So, its monomer is vinyl chloride. Like that, instead of a chlorine, you can have a double bond with cyanide. This is called acrylonitrile, acrylonitrile. What you will get is called what? Polyacrylonitrile, acrylonitrile. If a double bond is having a phenyl ring, it is called a styrene. So, what you will get polymer from the styrene is polystyrene, and so on. Like that, this group goes on changing, huge number of polymers. You can have a methyl group, propene, propylene, polypropylene, polybutylene and so on. Different types of the polymers depending upon this group, hanging group changing, variety of polymers can be prepared. This is what polymerization topic. Even alkynes also shows this type of polymerization, but not a very large extent polymerization is not there. Smaller molecules may be coming to trimerization, dimerization we find in the alkynes. So, let us go for the fourth property, that is it is a special property of the alkenes, under that allylic substitution, allylic substitution. So, before going to exactly the allylic substitution, let us observe that when a propene is treated with a chlorine, propene is a gas, right? It is a propene. Propene is a gas, and you also add the another gas, that is chlorine, into this gas. So, two gases does not require any catalyst. What happens when this chlorine will split up into plus minus, add one here, add another here, and you will get a product known as a propene with containing 2 chlorines at middle carbon 1, terminal carbon 1, you call it as a 1,2 dichloro propene is formed. This is what an example for the electrophilic addition reaction it takes place. This we have already completed under the first property. In fact, this is not I am not going to explain under this heading allylic substitution. What we are going to see is the same propene when treated with the chlorine gas under not this condition, but at 500 degrees centigrade. At high temperature we are heating these two at 500 degrees, then what happens means in this case the double bond will be intact, but one of the hydrogen from the methyl group is being replaced and the double bond is observed to be as it is. See that? Why not the addition taking place is first question. Why this substitution is taking place at this carbon CH3, why not at this side? So many hydrogens are there on the alkene also, but that hydrogens are not showing substitution. But the next carbon to this double bonded carbon, next carbon is called allylic carbon. On this allylic carbon substitution is taking place. Why this is happening is now the question. So first reason is at 500 degrees, this is not at room temperature. At room temperature means chlorine splits into plus minus, then adds one after the one, you will get two-step reaction takes place, you will get addition. But at 500 degrees the chlorine, because of the high temperature, it breaks homolytically and you are getting a 2 chlorine free radicals. This is called chlorine free radical. Then also we can argue that if free radical comes, then what happened? The radicals can be added. Radicals also undergo addition reaction because unsaturation is there. These 2 chlorines, one here can be added, and let us have the same type of the addition reaction. Why not? Then we have second explanation like this. If addition takes place, that means if radicals adds, if addition with radicals, okay, with radicals, not with the plus minus under the other case, with radicals if addition takes place, the propene will react with one of the chlorine. The chlorine may go to the first carbon, right, or it can go to the second carbon. So therefore 2 chances are there. If the chlorine goes to the terminal carbon, the middle carbon will become a free radical. If the chlorine goes to the middle carbon, then the terminal carbon will become a free radical. Either one will be a free radical, and both have got some stabilizing features also. This is a 2 degree one, comparatively when compared with 1 degree is more stable, but both have got some features also. It has got the 2 inductive effects and 3 plus 2 5 hyperconjugable hydrogens. This 2 has 1 hyperconjugable hydrogen and 1 inductive effect. Both are having some stabilizing features, it is not bad even. But the condition is at 500 degrees we are doing this reaction. Therefore, if addition takes place, the intermediate forms formed are not that stable. Both intermediate will give back the original one. They are giving the back by the process called decomposition, or breaks up. It breaks up again back, gives back the reverse reaction taking place, and you are getting the alkene formation is taking. Instead of this addition reaction, if you propose another type of if substitution takes place, if substitution at allylic carbon takes place, then what happens? So this third part we will see here. What happens? This substitution takes place at allylic, I will explain. The double bonded carbons have 2 and 1 hydrogens. Next carbon has 3 hydrogens. All these 3 hydrogens are showing a sort of phenomenon called resonance, called hyperconjugation. That is why the hydrogens are very reactive also. So therefore, at that temperature, the chlorine dot will replace the hydrogen, and what you will get is either one of the hydrogen. So let me write that hydrogen is replaced. So what you will get is a dot is formed. This dot and H forms into HCl, right? And then an intermediate, that is a double bond containing compound, is formed. This is what your intermediate at 500 degrees. I will explain once again. If the Cl dot adds on the double bonded carbons, you will get a saturated free radicals. If the chlorine takes away this hydrogen, showing a part of the substitution reaction, H is replaced, not at Cl is added, but Cl and H gone as HCl, and the intermediate is formed. This is called what? Allyl free radical. Allyl free radical. Allyl free radical. This free radical has resonance stability. So out of 2 electrons, 1 electron will come and this electron will come, double bond formation, this goes to here. So another free radical is formed. If the double bond is shifted this side, that side you will get a dot. So this intermediate has a feature called resonance stabilization, whereas here stabilization features are inductive effects and hyperconjugation. That intermediate is stabilized by the resonance stabilization. So resonance stabilization always a better stabilization, therefore the reaction gives a lot of amount of intermediate, and consequently one Cl dot adds on either here or here, and what you will get is finally the CH2 with a Cl. This side or that side makes no difference. So Cl containing propene, this is your final answer. So the why substitution takes place, why not addition, means we are giving 3 level answer. One, first level, the at high temperature chlorine breaks into free radical and free radical. You cannot have a Cl plus and minus which was there in the ordinary at room temperature. Second one is, if addition takes place with the dots formation, can have an addition also, adds on the double bond, you get 1 degree, 2 degree, both have got some resonance, inductive effect stabilization, hyperconjugation, but that is not much stable because at 500 degrees they decompose back and gives the alkenes. There is no much progressive reaction. But if substitution takes place at allylic hydrogen, which are having originally hyperconjugation with this one, highly reactive, so therefore that hydrogen, if it is replaced, that is Cl takes away, a dot comes that resonates, both are identical. In fact, any one of the dot, if it is attacking with this Cl dot, you will get a allyl chloride. So that is what the product I have shown, allyl chloride. The product is called allyl chloride. So this allyl chloride formation is explained under the 3 different headings. At high temperature, dots are formed. The dot undergoes addition, intermediates are not stable because of the high temperature. If a dot shows substitution on allylic carbon, intermediate is stabilized, therefore reaction takes place nicely. How can we say that the reaction taking place through this intermediate allylic free radical and so on, means we have some evidences to this extent to explain. Let us see. So an evidence for this allylic substitution is, for example, if I take a 1-butene, if I take 1-butene is treated with chlorine at 500 degrees. According to the previous theory, what I said is, these hydrogens show hyperconjugation, therefore one of the hydrogen which is detached with the chlorine dot, and a dot formed will have a resonance stability. So if Cl dot takes away this one hydrogen, you will get this intermediate CH3, a CH dot, CH double bond CH2. This is called an allyl type of free radical, but this is a butenyl, isn't it? This is not a allyl. 4 carbon compound it is, with a dot is specially allylic to this double bond system. Now this will have a, if this undergoes reaction, then naturally what product will come? If a Cl dot comes, then you will get a alkene will be like this, the halogen will come. But if this intermediate undergoes a resonance, then what happens? then the double bond will come to the center and the dot goes to the terminal, right. This is another intermediate. Let us call this as intermediate 1, step 1, intermediate, step 2, product. After getting step 1, instead of step 2, it undergoes a resonance, not rearrangement. In the rearrangement, what is the difference? Rearrangement means atoms should dislocate from one place to the other place, jumbling. That jumbling is not there. Atoms are as it is, see CH3. So, there is a CH, okay. There is a CH and this is CH2. So, same atoms positions is same, excepting the dot from middle carbon to the terminal carbon gone and the double bond is shifted. So, the shifting of double bonds, charges, dots, all that lone pairs is only in the resonance. So, this is resonance taking place, therefore, intermediate 1 has become into intermediate 2. If this undergoes a reaction with Cl dot, then what you will get is the double bond will be in the center, the chlorine will be here. Yes. So, theory is now, if this treated with chlorine, you must get this answer, but the intermediate shows a resonance and then Cl minus dot attacks, you also should get this one. So, that is what really observed also butene on chlorination with at 500 degrees centigrade. You are getting the two answers, answer 1 A, answer B, both are coming in fact. So, this B is coming, actually the product B formation is not that easy to explain. If straight away question, this is treated with chlorine, you got that one, write the mechanism means double bond originally in the between first and second carbon, now here it is second and third carbon, double bond is shifted one place, how it is formed means we cannot explain, but there is a beautiful explanation that the intermediate formed, if it is attacked by Cl, you will get answer A. If it is undergoes a resonance and then attacks Cl minus, you will get the B. So, there is A and B formation clearly shows that this mechanism is having a full support, and we have to believe this mechanism that the allyl free radical is having really a greater stability. That is why formation of allyl free radical, resonance gives another allyl free radical, which gives the another product. So, two products are forming. Similarly, a number of examples of this category can be taken, but before that we have some similar reagents, like for example, if this is treated with a SO2Cl2, this is called what? Sulfuryl chloride. Sulfuryl chloride. SOCl2 is there, that is called thionyl chloride. This is called sulfuryl chloride. Also will give the allylic substitution. That means here comes, if double bond comes, you also get A plus B, A and B, two answers will come even in this case. Instead of this thionyl chloride, somebody was identified also one more reagent. Especially he was studying the properties of this cycloalkenes. He studied that when it is treated with a succinic acid derivative. What is succinic acid? A 4 carbon dioic acid. Two sides acids is succinic acid. So, let us take a succinic acid with if O is there, anhydride, but NH is there, this is called succinimide. In this succinimide, instead of hydrogen, if I have a bromine, this is called shortly NBS. Now, what is NBS stands for? NBS stands for the N-bromo succinimide. NBS stands for N-bromo succinimide. This slowly gives a decomposition at this level, giving the Br dot and N dot. The N dot has got some resonance stabilization. So, therefore, slowly giving this reaction. It is explained that the free radical, bromine free radical concentration is very much suitable for the allylic substitution thermodynamically. So, therefore, the two hydrogens which are here are here, they are identical, isn't it? Either of these 4 hydrogens, one hydrogen which is allylic to the double bond. What I said is the carbons which construct the double bond is called vinyl, Next to the vinylic carbon is allylic. So, on the allylic we have 2 this side, 2 that side. Any one of the hydrogen is replaced and you will get this type of a bromo containing cycloalkene. Okay. This is called allylic bromination taking place. So, NBS is known for the allylic bromination. The reaction is also noticed as a Wohl-Ziegler reaction. Wohl-Ziegler reaction. Especially the reaction is studied on cycloalkenes to get this type of the product. We can have a 1 or 2 extensions of this category. Let us see. If the compound is a cyclohexene having one methyl group here, this is not cyclohexene, it is a numbering from 1 to 3, 3 methyl cyclohexene. Okay, 3 methyl numbering starts from here, it goes that side. If it starts here, it comes this side. So, 1, 2, 3, 3 methyl cyclohexene. Ene is at 1 carbon, understood. This is treated with the N-bromosuccinimide. NBS stands for the N-bromosuccinimide. Now, previous case the methyl was not there, so either on the top or bottom same answer will come. Now, 2 answers will come. One will be the by the side of the methyl, double bond will be there. This is the one answer A, plus even the other side also you will get one of the bromine may come at the bottom also. So, this is answer B. So, 2 answers are coming now. Bromination on the upper side allylic carbon or on the bottom side, both are allylic. Remember, it is an allylic substitution. For NBS and for the sulfuryl chloride, 500 degrees not necessary, but the same the conditions are allowed. So, 2 answers are coming. Surprisingly, you also get 2 more answers. 2 more answers are coming. How the 2 more answers means? What is the intermediate for the A? Intermediate for the A means, so from here the hydrogen is detached and you will get a dot here. This must be the intermediate for the A, isn't it? Intermediate for the A. And this, if Br dot attacks, you will get this one A. But if it undergoes a resonance, this undergoes resonance, then intermediate 1 changes into another intermediate, let us say intermediate 2. So, in which the double bond goes that side, methyl side, the dot comes here, this undergoes a bromination. So, therefore, there may be another product, the bromine may come here, double bond will be here, a methyl group. Let us see, this is answer C. So, C is coming from the intermediate 1 undergoing resonance to give the intermediate 2 and then undergoes this reaction. Or what will be the intermediate for the B means one of the hydrogen from here, if it is cut, then you will get this intermediate. This is called, let us say, intermediate 3. The intermediate 3 will be like this. Okay. If this dot is reacted with bromine, you will get this answer B. Instead, it may undergo a resonance. Intermediate 3 may undergo resonance, which gives a double bond this side and the dot goes that side. With reference to the methyl, this is different. This is different, this is different, right? So, the another intermediate that let me call as a intermediate 4. If this gives a answer with the bromine attacking, then you will get one more answer, that is the bromine will be under by the side of the methyl, this is. So, this let me call as a compound D. So, totally 4 answers are coming, A, B, C and D are coming. A and B, A and C are from the intermediate 1 A, resonance structure intermediate 2 C. if the bottom side hydrogen is removed, you will get intermediate 3 and that gives the B. Its resonance structure intermediate 4 gives the D. So, you get the all the 4 A, B, C, D in the as a answers, isn't it? So, the 2 answers are consequence of the resonance, A and B are direct the intermediates and they are coming. If the intermediate undergoes resonance, we are getting 2 more. So, if the product formation, if you carefully observe, one has to believe that the intermediate, if there is a chance of resonance, it is undergoing and giving another intermediate, then giving the product. That means, always the intermediate is a allylic free radical, which has got a resonance stability, and resonance if perhaps sometimes gives a slightly different type of intermediate, even that undergoes reaction, giving the another type of the product. Once this question was asked, instead of this methyl group, he said there is a carbon with star. The star means C14. That means generally carbon will be there, C12 carbons will be there. At this carbon, if C14 is there, then this with NBS what comes? That was his question. So, as usually we can say that one will be the at star we get a bromination, another one will be the down to the star bromination. This is second answer. Another one is its intermediate gives one more product. That means the dot will be here, double bond goes this side, isn't it? So, star will be here, that is bromine will be coming here. Okay. Another one is this intermediate, this star will be always here. The double bond will be coming this side and star will be here. With reference to the star, all these 4 are different now, right? 2 are direct answers, 2 are intermediate showing resonance and then giving the answer. So, totally 4 answers are coming, all are mono brominated only. If it is further treated, actually we can introduce 4 halogens, isn't it? You will get much more complicated discussion, but under the mono substitution condition, how many answers will come means 4 answers are coming. If this is not there, single answer will come. Either at the top or bottom, same answer. Resonance or without showing the resonance, intermediate changes resonance, then also same answer. All are nothing but the allyl brominated cyclohexene will come. Just because of the carbon is labeled, just like this methyl group introduction is also nothing but the label. So, these 2 are equivalent examples in fact. So, this was asked in one IIT examination in the previous years, asked how many answers means all the 4 will be obtained.